This is the viaduct of Pontevedra and we are going to solve it. First, we have to find the reactions of force, the summatory of X, Y, and M. The summatory for force in X is equals to 0. Gy is equals to 110.5 and Ay is equals to 110.5. Let's start with node A. We have that the summatory force in X is equal to AB plus AM cosine 52.43. We have this angle with the inverse of tangent and we equal to 0. Then the summatory force in Y is equals to 107.5 plus AM sine 52.43 equals to 0. We clear the equation and we have that AM is equal to minus 133.85 and AB is equal to 81.61. Well, node B is the reaction, so AB is going to be equal to BC, 81.61, and BM is going to be equal to the force that we have, that is 20. Then in node M, we have our angles, and the symmetrical force in X is going to be ML plus 133.85 cosine of our angle 52.43 plus MC cosine of 52.43 equals to 0. And the symmetrical force in Y is going to be 133.85 sine 52.43 minus 20 minus NC sine 52.43 and equals to 0. We are going to clear the equation and we have that MC is equal to 108.62 and MEL is going to be minus 147.84.
The next thing we have to do is solve node N, and we can see that NM is 0 and NA is equal to 0. So for node L, we only have one force and is acting in the axis X. So we have that LK is equal to minus 147.84 and LC is equal to 0. Next, for node C, we have a lot of forces, and when we clear the equation, we find that CD is equal to 214 and CK is equal to minus 58.62. And finally, for node D, we have that DK is equal to 75 and the A is equal to 214.1.
Hello guys, my name is Eduardo and I will show you how to use the sections method to solve this problem, right? This method is quite easier than the last one because you only have to do a section in whatever part of the bridge and you will know the forces. But you need to see what happened with the bars when you when you do a section, right? We have the section 1, 2, and 3, and we will be solving this section, okay? We're going to start using the joint A, but how do I know which joint use? Because we have, from the section to the left, the joint A and the joint N. How do I know which joint use? I know it because in this joint I have 3 bars or 3 forces being in that joint. But if I use the joint N, I just have these 2 forces and it's useful. If we have more than 3 forces, it's impossible, right? As we know, it's impossible. Okay, we are going to use the equilibrium formulas, and we're going to start with the sum of forces in X. That equals to 0, and the direction, and the positive direction, go this way, okay? We have in this layer diagram that that 3 forces is in X. Is in M, the force or the bar in M, plus the force or the bar AB, plus the force AM. But what happened with AM? AM is in a diagonal, right? So we're going to put this like cosine because we are of the degree, that is 52.43, the angle, 43 degrees. Okay, we have this angle, and all this is equal to 0 to be in equilibrium. In this part, at this moment, we can continue because we have 3 forces that we don't know, but we will be using the next formula, that is the sum of the forces in Y that equals to 0. The positive direction is this way, and we know that it's AM sin of 52.43 degrees plus the external force, that is 107.5. 107.5, and this equals to 0. We are solving for this, and it's AM equals to minus 107.5 divided by this part, that is sin of 52.43 degrees. Okay, the answer for this is AM equals to 135.6 kilonewtons, right? We have this force. Now, we don't know 2 forces of this, so we need to be using the sum of momentum. We're going to write it right here. 135.63 kilonewtons, sorry. And we are going to continue with the sum of momentum. The sum of momentum equals to 0. The positive direction is this way. What does this mean? That if the momentum goes this way, this will be negative, right? But we need to know that if we are in the node A, the forces that go through the joint are not going to generate any momentum. But why? Like an example, if this is a rope and I'm right here and I pull the rope, this will not generate any momentum, right? But if I am right here, this is a rope, and I am right here, this will be generating a momentum into this direction, right? So the only one or the only joint that generates a momentum is the force or the bar NM, because these 2 bars are not generating any momentum. Okay? Well, continuing, I will put NM equals to 0. But for the momentum, we need to know the distance from the joint to the force. That is 6.5. like this. This is the joint, and this is the force. This distance of right here is 6.5, and it will be multiplied by nm. And m multiplied by 6.5 equals 0 because it is the only momentum. What happened here that we all know that nm equals to 0. That's all. Continuing with this part, we already know two of the three forces that we didn't know. That is this one and this one. And then we will be solving for AB. AB plus AM, that is negative, this part is negative. So it's plus 0, this part is 0, plus, well, minus 135.63 cosine of the angle, that is 52.43 degrees. This equals to 0, and if we are solving for this one, is AB equals to 135.63 cosine of this angle, and we know that AB equals to 82.69 kilograms. Now we know the three forces for this joint, for this section. Right in this moment, we have the answer of the three forces, and we can continue with the other two sections. So it will be the same process, okay? I will write it right here. It will be equal to 82.69 kilonewtons, and n equals to 0 kilonewtons. Okay? We will be solving the other two sections with the same process. The second section, we are going to do exactly the same process as section 1. I will be using the joint M because it has the three bars or the three forces that the section cut, okay? Right here. So we will start with ML plus BC plus MC plus MC, but if the MC is a diagonal, it will be in the S cosine of 52.43 degrees. All this equals to 0. Okay? At this point we can continue, but we can start with the forces in Y. Okay? Right here we have MC sine of the angle plus the external forces. The external forces are these two, 107.5 kilonewtons and 20 kilonewtons. But 20 kilonewtons is going in a direction that is called negative. Okay? Right here we have 107.5 minus 20, all this equals to 0. Okay? This is minus because of the direction. Now, we are going to solve MC, and MC equals, this is 87.5 divided by sin of 52.43, and the answer for this is 110.39 kilonewtons, right? So I'm going to write it right here. and C equals to 110.335, right? The 39 kilonewtons. Okay. Then to find out these other two, I will be finding out BC with the sum of momentums, right? The sum of momentums is BC multiplied by 6.5. This 6.5 is this distance of right here, okay? We are going to use this external force that is generating a momentum. So it's plus 107.5 multiplied by 5 because of this of the bridge we have right here. So it's 5 and it's the momentum, it's going this way, okay? So it's 5. Why don't we put the 20 like momentum? Because it's going through the joint, and as we know, if a force goes through the joint, it don't generate a momentum, okay? Well, this equals to 0, and then BC equals 537.5 divided by 6.5, right? This means that BC equals 82.69 kilonewtons, sorry. So we are going to write it right here. BC equals 82.69 kilonewtons. And to find the last force is just going right here this data. We got it. So ML plus BC, that is 82.69, plus MC, that is 110.39, cosine of 52.43 degrees equals to 0. Okay, continuing, it's ML equals to 82.69 plus 7 plus 67.3. 67.3 is this formula right here, okay? So ML equals 150 kilonewtons. And there we have the three forces. ML equals 100.